Alright, well, and to start with, you could see something. The directions will simply say divide, and you could see a polynomial, and this first one, we're going to divide by a monomial. And they're a little bit easier than most of the others, so we'll just begin with that and show you that. So let's say I have that great big polynomial divided by this monomial, one term. So when you see it like this, you can think of it in your head as this term over this term. Subtract this term over this term, plus this term over this term. Subtract this term over this term. And if you wanted, you could take a step and write it, but I'm going to hope you all understand that and reduce. So if I reduce the first one, I would have 9, and then a squared would reduce with 2 of those, and I would have 1a, and then this b would reduce with 1 of those, and I would have 2 b's. And remember that you subtract exponents, so 3 subtract 2 is 1. 3 subtract 1 is 2. And then in the next term, now I have this set, this over this. This is my numerator, this is my denominator. So reducing it, the a squareds reduce completely, and the b, I only have 1b left on top. Subtract, now in this term, the a squared divided by a squared is 1, and b divided by b is also 1. So don't forget the 1. Sometimes people just cross that off and it's by dividing by itself. In the last term, I still have that 4 on top, but this one's a little bit unique because look, I have a on the top, but I have 2 a's on the bottom. So if I reduce that, I'll be left with 1a on the bottom, and this b is still on the bottom as well. Just reduce. Now, if they give you this, for example, maybe they'll give you a polynomial like this one. And they'll say, divide it by this. Now, you're dividing by a binomial with 2 terms. And so, we're going to do this just like you did long division when you were a kid. So let's review really fast. Let's suppose I wanted to divide 5 into 618. Well, in my mind, I would go, what times 5 is close to 6? Okay, 1. So I would say 1 times 5, then whatever I put up here, I go 1 times 5 is 5, and I put it right there. And then I subtract, right? Do y'all remember this? 6 subtract 5 is 1. And then you would bring the next term down. So I'd bring that 11 down. And then you would repeat. 5 goes into 11, and so forth. So we're going to use that as kind of our guide. And we're going to do this using long division, just like you did with numbers back then. So let's see if we can make the steps make sense. And then if you ever forget it, you can just go back to regular division, and hopefully it'll come back to you. But the thing about polynomials is you only have to look at the first term. So I'm going to say, how many times does x go into 5x to the third? Or, in other words, what do I have to multiply x by to make it equal 5x to the third? And I would need a 5, and I would need 2 x's, wouldn't I? Now, we know in long division with normals, it's really important to keep it lined up. In long division with polynomials, it doesn't really matter. You can put it anywhere up here. I tend to line it up with like powers, but it's not as critical. Alright, now I'm going to go 5x squared, and I'm going to times it by this whole binomial. So 5x squared times x is 5x to the third, and 5x squared times negative 2 is negative 10x. And you probably didn't even think about that. You just knew to do it. And we're going to do the same thing now. And so you can do that one of 2 ways. You could write it in parentheses like this, because the key is that you remember that you have to distribute that negative. So it will change every single sign. So this becomes negative now, so these are gone. And that's what should always happen. If it doesn't, something's wrong. You've made a mistake. Plus 10x squared. So this will be 6x squared. Then, after we subtracted, we pulled down the next thing that comes with it. Now I go, what times x is 6x squared? And I know I have to multiply by a positive 6. And so now whatever you put right there, you multiply by this whole binomial. So I go 6x times x is 6x squared. And 6x times negative 2 is negative 12x. And now, this is what I like to do. If I'm going to show you in multicolor, instead of writing parentheses, what I will do is just change every single sign. But if you don't have multicolor, or if you might forget, you might want to make a note to yourself that you distributed a negative. That's why the signs changed. And those cancel. And then those now I have, when I combine those, I have 15x. And I just go ahead and pull the next one down with its sign, so I have minus 4. And now you keep going until this exponent, x times 15, is 15x. I will multiply by 15. Now 15 times the whole binomial is 15x minus 30. And then I know I have to subtract, so I change every single sign, or write it in front of parentheses and distribute it through, whichever you like. Here they cancel, which was our point, and here I have positive 26. Now, this exponent is smaller than this one, because there isn't one, so it must have been x to the 0, which is just 1. That's why there's no x. So this exponent is smaller than this one. So that's how I know this is my remainder. So once I have my remainder, I would write plus that remainder divided by whatever you divided. So that is your solution to this problem. Okay, and this one's kind of mean. How about this one? 3x to the 5th minus x to the 3rd plus 4x squared minus 12x minus 8. And we're going to divide this one by x squared minus 2. Again, we're going to do one more long division, so I'm just going to write it out, but here's what I'm going to do. Notice that this one goes from x to the 3rd to a constant. So it skips the x spot where we might have an x, and so to make sure I keep like terms lined up, I'm going to put a 0 there. And then I'm going to put my minus 2. And I'm going to divide that into 3x to the 5th. And once again, it just happens to skip x to the 4th, doesn't it? So I want to keep like terms lined up, so I'm going to put a 0 where x to the 4th would be. And then my x to the 3rd, my x squared, minus 12x, minus 8. Ooh, almost ran out of room. Okay, so what times x squared is 3x to the 5th? Well, I know I need a 3, and I know I need 3 x's, don't I? So, because x to the 3rd plus x squared will be x to the 5th. Now you multiply this by the whole trinomial. So, I have 3x to the 3rd times x squared, which is 3x to the 3rd times 0 is 0. And 3x to the 3rd minus 2 is negative 6x to the 3rd. Now, the all-important thing to not forget is to subtract. So change every single sign. And that should make your first term cancel. And if it doesn't, you know you've made a mistake. Now, in this case, these cancel too. And this is ironic, because this is unusual that the 0 in this lined up with the 0 in this. Typically, that won't happen. And you'll see later in our problem that we'll need this 0 to keep things lined up. But that's just pure coincidence that those happen to line up in this case. And now I have negative 1 and positive 6, so I have positive 5x to the 3rd squared. Now, because I have 3 terms here, I want 3 terms here. So I'm going to bring down the next term. Start again and go, what times x squared is 5x to the 3rd? And we know we need a positive 5, and we need one more x, don't we? So now I'm going to multiply this times all of this. So I get 5x times x squared is 5x to the 3rd. 5x times 0 is 0. And that's important, because now you're going to see that if I had done 5x times negative 2 right there, I would have that negative 10x under the 4x squared. And I might be tempted to add something that is not like terms. They would be lined up, and I might want to add them. By putting the zeros there, they stay lined up. So, change in the signs, because we're subtracting 4x squared minus 2x. And then I just have to pull the last one going, and I go, what times x squared is 4x squared? And I know I just need a 4, don't I? And then timesing the 4 by this, I get 4x squared, and 4 times 0 is 0, and 4 times negative 2 is negative 8. And then changing every single sign, the 4x squareds cancel, and even the 8's cancel, but the negative 2x is there. And that's important because that means my answer is the 3x to the third plus 5x plus 4, and this is my remainder. So I could say subtract, or I can say plus negative 2x, all over what you divided by, x squared minus 2. So that's our solution. Okay. Now, that's pretty long. And so mathematicians found a short way to divide, and it's called synthetic division. Is that you can only use it when you're dividing by x plus a number or x minus a number. So I'll use a for anything. But if you're using, and we do this a lot in math, sometimes to help us find zeros, for lots of reasons you might want to divide by x plus or x minus a number. So this synthetic division. And lots of students really like it because it's not nearly as long. However, you have to remember some things. It takes some memorization. So let's try it. Let's say I have 3x to the third minus 2x squared plus 5x plus 4, and we're going to divide that by x minus 2. Okay, so if I'm going to do it using, I know that I see that's just x minus a number, so I can use synthetic division. So if I'm using synthetic division, what you do is you figure out what x equals in that divisor, and you put that number in a little box right here. Then what you do is you just write every coefficient. You don't even have to worry about the x's, as long as they go down. Look, x to the third, then x squared, then x to the first, then the constant skipped. So I just write the coefficients, and don't forget their signs. Keep their signs with them. If they're positive, you can just write the number. If they're negative, you have to put that. And here's what's nice about synthetic division. You skip one line, and the next line will be your answer every single time. Now this is what you have to memorize. The first step every single time is just to pull that 3 down. So I'm just going to pull whatever I see up there down. Now I multiply the box number times what I just pulled down. So 2 times 3 is 6, and I'm going to put it right there. Then, unlike long division, all you have to do right here is add. So negative 2 plus 4, repeating, 2 times 4. 2 times 4 is 8, and it will go right there. Add, so I get 13, and repeat. 2 times 13 is 26. And add, and I get 30. So what I just learned is that 30 is my remainder. So I'm going to write it over what I divided by. And it's positive, so I will say plus. This is my constant, this is my x, and this is my x squared. And there's no negatives, so they can all say plus. And that is your answer. Done. And here's a note. Whatever you started with, if you divide it into 3x to the third, your answer will always be 3x squared. So some people like to do that and just start with the biggest and go down. They both plus 3x to the third minus 5x plus 4. And I want to divide that by x plus 1. So once again, if I set that equal to 0 and solved, I know that in my box would be negative 1. And that's what, in my mind, I always just do the opposite sign. So this one was subtract 2, you put positive. This one is positive 1, you put negative 1. Or set it equal to 0 and solve. Then write the coefficients. Now in this case, look, we go x to the fourth, x to the third, and there's no x squared. Then we have x to the first power, and then we have our constant. So I have to keep track of that, or in synthetic division, it won't give you the right answer if you don't remember for the x squared, because there's no x squared. So writing the coefficients, I write 1 for x to the fourth, 3 for x to the third. There is no x squared, negative 5 for the x, and 4 for the constant. And like before, we just skip one line and draw a line. Then, don't forget, pull the first number down, nothing changes. Multiply, negative 1 times 1, and that is negative 1. Add, multiply. Add, multiply. Multiply. And add. Now, if you like it, you can start with the remainder and go up. Or, here's the other option. I started with x to the fourth, and I divided by x, so I know this first term will be x to the third. So I have 1x to the third minus 2x squared minus 2x, and that's coming from this. Oh, this is plus, because that's positive 2x squared. This one's minus 2x squared. Minus 3, that's my constant, plus my remainder over what I divided by. So be careful. If this is positive, this is plus. If this is negative, this is subtract. Our answer. We're done. All right. Good luck on 6.4.